This is a recording of a live webinar filmed on August 16, 2023, the first in our four-part series entitled Expert Insights, Industrial Efficiency. Join us for the 3 remaining live events, August 23rd through September 6th, covering cleaners, pretreatment, and water treatment. Click the link in the description to learn more or to follow us on LinkedIn to be in the loop of upcoming events.
I want to thank everyone for jumping on to this call today. We decided, we want to do this webinar series because, again, we have FabTech in a few weeks, which, we look forward to seeing anybody there. But also, in this time, there's a lot of uncertainty about where the economy's going. Everyone's trying to look to save money, as well as, some of the environmental impact that we're having with some of our products. So we wanted to focus on industrial efficiency and sustainability. So we have this series of webinars in order to discuss and talk about that. So the webinar that we are running today, it's going to be Expert Insight into Metalworking Fluids, Solutions to Extend Chemical and Equipment Life. And the people we have presenting today, we've got Bruce Kaler. Bruce Kaler, he came over to DuBois from our Simcoe acquisition a few years ago. Bruce has been in the metalworking fluid industry for over 40 years. He's been in quality control. He's been a formulator. He's been out in the field. He's worked through distribution. And right now, he is currently a senior product line manager for the metalworking fluid line. And on the call today, too, we also have Marty Berg. Marty has about 35 years experience in the industrial chemical industry. He's been with DuBois about 18 years. Marty specializes in metalworking fluids. That's the main reason we have him on the call, but he's also very knowledgeable in heat treatment, forming in general, cleaning, rust preventives, lubricants, everything along the line. He has spent most of his time in the field trying to seek out the right products to help make your process the most efficient that it can be, make them last the longest it can so you get the most bang for your buck. So with that, I'm going to turn it over to Marty and Bruce.
Very good. Thank you, Max. So as Max said, we're going to kind of spend the next 40 minutes talking a little bit about metalworking, how the fluids are utilized in the facilities and what kind of impacts they have. So we put this little diagram together a number of years ago. It's one of the ways we can explain the complexity of DuBois. You can kind of see as we go around this cutout of a manufacturing plant, all the different areas that chemistry is introduced: metalworking fluids, water treatment, wastewater treatment, preparing for paint booths, maintenance cleaning, surface cleaning, drawing and stamping, transportation, and then just the general lubricants for the machines. We do all of it. So we're intimately involved with all of these processes in the manufacturing plant. But for today, we're just going to focus in on the metalworking fluids. So let's start with some of the key functions of these metalworking fluids. They're there to cool, provide cooling, remove the heat from the point of cut, lubricate, provide rust protection, especially for freshly exposed metal. They're very sensitive, but even for the equipment itself, the machines, and then carry any swarf or particulates, chips away from the point of cut. But you'll notice it's no accident that cooling is the top one, because we even call these metalworking fluids the water miscible ones or water dilutable ones. We call them coolants all the time. It's just part of the vernacular, and it's because that is the biggest value that they bring. So as I mentioned, the cooling, most important feature of the products, these excessive temperatures are being generated at the point of cut between the tool and the work surface itself. If it's allowed to get too hot, we can ruin the integrity of not only the surface of the metal being machined, where we'll get like a burning effect or work hardening, but also we'll end up wearing the tool much more quickly than we need to. So its function is to remove the heat so that our customers can go faster. I think that's something we all see and feel. We're going as get these machines to run as quickly as they possibly can, and then also to reduce the friction between the tool and the metal to extend that tool life. So what types of lubrication are we talking about? There's really 3 major categories. There's boundary lubricity, extreme pressure, and hydrodynamic. Boundary lubricity is just like it sounds. It's just a lubricant you can feel between your fingers, sometimes called thin film lubrication. Though they're typically liquids, Every once in a while, someone will sneak a solid in there like Moly D, molybdenum disulfide. We use things such as oils and esters and olefins, all these big fatty molecules that actually provide really good lubrication between the workpiece and the tool. And these fluids also might have boundary lubrication with a combination of EP lubrication to enhance performance. So I just said EP. What is EP? It's extreme pressure components. So the most popular are phosphorus, chlorine, and sulfur. They come in a variety of molecules. You'll hear chlorinated paraffin, sulfurized olefin, phos esters. But they can jump back and forth. As you might expect, we're trying to get the best performance at the best cost. So we're always going to look for the most economical way to deliver these. And their function is they reduce the heat at different, as the pressure and heat build at that point of cut. So it kind of creates a little chemical change at the workpiece, right at the tooling interface, and provides that additional lubricity when activated at high temperatures and pressures. You can't feel the EP between your fingers because when you rub your fingers back and forth, you're not creating enough pressure or heat to actually activate that. Hydrodynamic lubrication. So, think of the word or hydraulic oil. So it's the same thing. These is just allowing for two surfaces to pass each other without scratching or galling. So they can't carry a load. They can't actually provide as much lubrication as we would like to, but they are used in combination with these other lubrication packages. I love this slide because it really does. It gets us to start thinking about what really is happening at the point of cut. So obviously we have here the green piece is the work piece, and the red little somewhat rectangular is the tool, and then the yellow is the chip that's being actually taken off of the part. And the reason I like this so much is I always point out, so where the red, the green, and the yellow are meeting, how much fluid is there? And the answer is there's none. It's metal to metal contact. So what are we doing then? If we talk about lubrication, we're talking about cooling, is we're trying to get that heat away from the point of cut. So as a result, most of that heat is actually being carried off in that chip. I don't remember the number, but it's up in the 80s. So if we can get that chip away from the part and the tool and quench it, if you will, or to cool it down with water hitting it, a water-based fluid hitting it, that's one of the main goals we're trying to do. But there is lubrication. We're just lubricating the chip as it's coming off and it crosses the edge of the tool. So another really important function of these metalworking fluids I mentioned before is the rust protection. We're trying to protect the part as it travels through the plant, maybe from operation to operation, protect the machine itself, the machine tool, which will have a lot of bare metal surfaces itself. And then, oftentimes our customers will need longer term storage protection, which requires an additional rust preventative. But these fluids will provide, easily 7 to 10 days. You can stretch it out. I mean, customers will get a month, but we have to be careful and make sure we're providing really high quality fluid if we're going to rely on it that long. So I mentioned that one of the features is that it carries the swarf and particulates away. I'm gonna sound like a really weird guy here. I love the picture on the right. That's a really, really good cake of swarf. That's a pressure filter, where the cake, if you think about it, there's a piece of filter media below the cake on the bed of the filter. And as that cake builds, it creates a more circuitous route where the fluid has to flow through and gives you better filtration. Plus, the customer is going to benefit from being able to landfill that swarf, depending on the material, but in most cases, they'll be able to landfill that because it's dry. And then on the left, we just have a representation of a lot of different type chips. And we want to remove them from the work area because they'll abrade surfaces. They'll either scratch the tooling, which again is going to lower the life of the tool, maybe scratch the parts, maybe scratch the operator's skin. All of a sudden we start abrading skin and we end up with a dermatological issue, and we certainly don't want to do that. This is another little chart we put together. There was a group of us and a customer, and we were really being asked a lot of questions about how we choose the products that were in the plant, because it was a big facility and there were a couple different products in there, and we kind of got a got on a little whiteboard and we started kind of diagramming it out, and we ended up with this diagram. And again, no accident. On top here is the water quality. It's paramount. It's when we're going to choose the right product, and Meg's kind of alluded to it earlier, is one of the things Bruce, Pam, and I do is we help select the right products. We've got a really wide, really deep portfolio. Just on the metalworking side, there were 7 of the companies under the DuBois umbrella that made their own metalworking line. So we have a lot of experience. We've got a lot of talent. We've got a lot of different technologies that we can pull on for our customers. But if we pick the right product, then we're all going to be much happier. The customer is going to be happy because the performance is going to be good, and we're just going to be able to enjoy a nice long relationship. So understanding all these parameters that impact the coolant performance helps us pick the right product. So, like I said, water quality is important. It is what it is. If a customer's got a well and they're going to utilize the well, then we have to make sure we pick a product that's going to work with well water. If they're going to, polish the water because they have a big DI unit, because they maybe have a paint line in the plant and everything's available in deionized water, we need to know that too. So, the chemistry, what types of filtration, how much tramp oil is going to get in, what's the dirt load like, what type of tooling are they using, and then the control plan. And this is usually where if I do something like this in person, somebody will usually ask, say, what do you mean by control plan? I say this and it sounds like I'm being flippant, but I mean it. I won't sell or recommend a synthetic to a customer that doesn't plan on using a refractometer on site to check the concentration. The concentration is going to go up very quickly. They're going to have all kinds of residue issues. They could actually have dermal issues with the operators. It's just not fair to any of us. So as a result, I kind of dig my heels in, and if you have a refractometer, I'm going to ask to see it. I'm going to calibrate it for you, because oftentimes people haven't seen that before and they didn't know that it had to be done. All those good things, but if they've got the ability to control the concentrations, then any product's available. So again, in that product selection, some other variables that impact how we pick them. What are the applications? And a lot of our customers are trying to run the plant on one product. And often when someone tells me that, I usually hold up 2 fingers and go, you can get to 2. I think usually 1 is a bit of a stretch, but we can do it. But you make some compromises. So what are the different applications? What type of materials are being machined? What type of machine tool, the cutting speeds, what type of finishes you're looking for. Are there any chemical restrictions? A good example would be aerospace, nuclear, and body parts. Anything that goes in, even a stent or a rod or screw, up to as complicated as a knee or hip replacement. You can't use a chlorinated paraffin. So if we know that that's what they're doing, then we just don't even go down that path. As I mentioned before, water quality is a big consideration. High pressure through the tool, delivery of the fluid. So it's a brand name, Chip Blaster. There's others out there, but they're the ones that came up with this concept. And we'll spend a little time on that later. But they're very, very helpful, because they do what their name says. They blast the chip away. And if you remember a couple slides ago, I said that most of the heat is being carried away in the chip. And then finally, any disposal or waste treatment concerns. Another example of that is we've got a lot of customers that will do their own waste treatment on site. And if we have a chelator in the product, that sometimes can cause them fits on the treatment. So we just make sure that we don't have that in there. So what type of applications are we talking about? So the main category is drilling, tapping, milling, grinding. There's subcategories. You can have gun drilling, center point, tapping. There's cut and form tapping. Different types of milling. Grinding at centerless, form grinding, crush grinding. There's all kinds of these great aggressive grindings now, as well as the different wheels that are being introduced in the marketplace. Going from the old standard vitrified wheel into CBN and diamond and ceramic. There's been some real advances in there, and so we have fluids that accommodate all those abrasives. And as I mentioned before, I'll spend a second here on chip lashes. So it delivers the coolant through the spindle, through a hole in the tool, so that it comes right at the point of cut, and it basically does blast, or it kind of sprays the fluid away from the point of cut, and it has a tendency to break those chips off. Now, those of you that have some experience in tooling, you know that there's a lot of tools have a little nub on there that's made to break the chip away too. This just does it a little bit faster, gets the chip away a little bit quicker. And if you look in the bins where the chips are collected, you'll see they're very, very small. So what we're doing is we're actually getting that heat, the chip, as fast away from the tool and the workpiece as we can. And this does extend the tool life. They do have a separate little tank that can be left idle for days. And this can be a bit of an issue because if it's left to sit too long, it's a great opportunity for bacteria to come in. They also have very tight filtration. So, they're trying to protect these pumps that are delivering between 1,000 and 1,500 PSI. So as a result, they're expensive. So they have very tight filtration. So going back to that product selection diagram I had with the droplet oil in the middle, this is something we need to know so that we don't have something that's going to get filtered out. So what type of metals are being machined? And again, when I'm doing some training for some of our own employees, I always spend a little time in this slide, but I always point out one thing too. A lot of our customers, if we ask them what are they machining, they'll say whatever comes in that door. So then we just have to make sure we pick a product that accommodates all metals. But we do have a lot of customers that still specialize. They'll have long runs, or they're making parts just for their company, like in the automotive industry. So we have a lot of customers that just machine ferrous materials. So the ferrous materials require the greatest amount of rust protection. They're very sensitive to rust. They're actually not that difficult to machine. So as a result, it's one of the major considerations is we want to make sure we're delivering the optimum amount of rust protection. And then we get into the alloys, stainless, aluminum, cast aluminum, things like that. These require higher levels of lubrication. And I'm going to show you how dumb I was when I got out of college. I got hired out of college by a coolant manufacturer out of Chicago. And when we started talking about aluminum, I'm like, what do you mean it's hard to machine aluminum? It's so malleable. Why would it be hard to machine it? And that is why. It's because of its malleability. You can end up with tool weld. You start pulling threads out. The customer puts a whole bunch of work and value into a part, and then all of a sudden, because we didn't provide enough lubrication, we scrap the part. And like I said, the pulling threads out seems to be the biggest complaint. And then when we get into the yellow metals, copper, bronze, leaded bronze, brass, these require chemistries that minimize residues. These have a tendency to very easily solubilize, and they'll create these metallic soaps. And the soaps end up consuming a lot of product, but they also become a real nuisance. They clog filters, they stick to the machine, and then chips stick to the machine. And remember a few minutes ago, I said, we don't want to break the operator's skin. We do not want to ever negatively impact the operator. This is just an opportunity to make sure we don't do that. So we have customers that do brass every day, and we actually have special chemistry for them. So when we start talking about the different types of metalworking fluids, there's really four main categories. There's straight oils, simple as it sounds. They're 100% oil. They can have all kinds of different viscosities. So that's the resistance to flow, or let's say how thick they are. They might have chlorine, sulfur, all kinds of performance enhancing additives in there. The great thing about straight oils is that they're impervious to any bacterial or fungal attack. They last a really, really long time. They very cost effective to use, except for the fact that they're messy and you have to clean them, and they mist more than water-based fluids. And then we get into soluble oils. That's where the industry started, kind of after World War I, where we started mixing water and oil that didn't want to go together. And we developed some emulsifier packages to disperse the oil in the water. And, they often have, again, other additives in there, can have chlorinated paraffin, sulfurized olefins, the esters and all those other great goodies that I referred to before. To help them perform better. And these are typically going to contain a bactericide to help protect them from that bacterial attack. And then we get into semi-synthetics. These are lower oil content. They have kind of, just like their name says, they've got some of the attributes of synthetics and some of the attributes of soluble oils. They're really good lubrication, good heat dissipation. They have good rust protection, longer sump life, less carry off, so because they run cleaner. They're a little thinner, if you will, if you want to do it that way. And then we get into synthetics. These contain no petroleum at all. Most of them, if not all, have a polymer in there and surfactants that provide the machining performance we're looking for, as well as the rust protection. And among these types of synthetic fluids are the best for heat reduction because water displaces heat better than anything else.
Hey, thank you, Marty. This is Bruce. I'm going to talk a little bit about the product. So this is the commercial part of our program, for lack of nothing else. But I wanted to talk about a few products and tie in some of the terminology describing these products that Marty had already talked about. The main metalworking fluid usage are for cooling and or providing lubrication. Simtech 310 is one of those products that does both. It is a synthetic, per the definition, does not contain any mineral oil. It is near neutral pH, so it's a pH around 7.6 to 8.0 on the pH acid alkaline scale. And it also meets Boeing BAC 5008 specifications for areas 5 and 6. Okay. But what makes this product unique is it's water-based, so its main function is cooling. Nothing that dissipates better than water. But it also provides a nice lubricant package in it that would be described as, in a sense, it's an extreme pressure additive in the fact that it unwraps at certain temperatures, called a cloud point. It doesn't react with the metal, so it's not a true EP. It's more of a boundary lubricant. So when the tool hits the workpiece, there's friction involved. Friction involves heat, and then heat will activate the cloud point, and the lubricant will coat the workpiece and the tooling, thus making the cut more efficient. So that's the basis behind this product, and products very similar to that. Okay, it's also well built to handle high pressure. The product is tested internally at 1200 psi in DI water, holds up well to high pressure, small sumps, and stuff of that nature. It is subjective. When subjected to extreme hard water, you could have some issues as far as residue goes. So while we all strive, us and our competitors, for the perfect fluid, none of us have reached it yet. But we're striving, and this is the type of chemistry that will get us there at some point in the future. So basically what we have here is a synthetic that provides cooling, works well in high nickel type alloys, titanium, and nickel-based product. Why? Because those metals tend to work harden under stress, under extreme heat. So we want to remove the heat away from the workpiece so we don't induce stress into the workpiece, causing some issues. So nobody wants a crack in the fuselage of their airplane. So anyway, that is this product in a nutshell.
Okay, next we're going to talk about the ProCool 710. This is more of a medium duty, not as heavy duty as the 310. It's basically designed for cast iron ferrous machining. Mixes in all kinds of water. It's got very low foaming. Pleasant to no odor, gentle on the skin. And one of the things that synthetics often do is they reject the tramp oil very effectively. And I can't actually tell you why, but it does seem that when we get into cast iron machining, we end up with machines that do have a tendency to leak more tramp oil. So this is a feature that's often needed, helps with cleanliness, help maintain that consistency in the fluid over time, got good bioresistant properties, and gives good stain and rust protection. This is our best-selling semi-synthetic, ProCool 5250. It's very versatile, biostable, no phenolic, medium oil content, designed for just a variety of machining operations. This goes to the, what type of machining are we doing? We do everything. So that's they could do everything from grinding to broaching. I'm not saying that would be necessarily the perfect product I would pick for it, but when I got customers who are looking to run one product, this is often a very good choice. Mixes in all water. It has low foaming. Again, it has a low to light odor, very minimal. Looks a little bit like whole milk when it's mixed with water. provides great cooling and rust protection. Matter of fact, that is the feature. And if you think about a couple slides ago when I was talking about when we're picking a product for ferrous machining, it's about rust protection. This product of our water-based metalworking fluids, I'd say this one provides the best rust protection. And it contains a really good lubrication package.
The Simpulse 53 MP is our new technology fluids out of DuBois. Basically, a traditional formulation, you will, of any oil-containing product would generally contain mineral oil, a sulfonate, typically a sodium sulfonate, sometimes a calcium sulfonate, and tall oil fatty acids and some amides. So you react the tall oil fatty acids with amides to form a soap, creating some boundary lubrication. The problem with those types of chemistries, and I say problem, there are many of our fluids that contain those chemistries. So, but this type of technology that we're calling the Simpulse brand, it basically removes the tall oil fatty acids, does not use traditional sodium sulfonates, and does not use certain biocides that are considered unattractive to the end user. So what does that mean? We replace the sodium sulfate with low foaming surfactants, and then this particular product does have a defoamer in it for high pressure. However, in this case, because we're using low foaming surfactants, the defoamer is in there solely as insurance. Basically, the kick-in period of any metalworking fluid trial, which is typically the most, I use the word dangerous, but it's the most susceptible time for foaming because there'll be some residual cleaners, some cleaners and stuff like that. But this product, I call it a semi-synthetic because in its formulation, it does contain mineral oil. It also contains a pretty good slug of water, which is the pure definition of a semi-synthetic. However, the oil level puts it in the range of a soluble oil. If you recall the slide that Marty just talked to, greater than 30% oil would be considered a soluble. But so this product has more than 30% oil and a good slug of water. So it could be called semi-synthetic or soluble oil, depending on your definition. But anyway, what makes this product attractive is it's very good aluminum machining fluid. It's a great machine shop for general use. It's very versatile. You can use it on steel. Its sweet spot is aluminum. It does provide foam control at high pressure. And if any of you recall, our first entry into this portfolio type of products was 51 MP. This is the next extension of that, 51 MP plus aluminum corrosion protection, enhanced aluminum corrosion protection, and improved foam control overall. But this is our fastest growing product, and it can be used to replace soluble oils and or semi-synthetics. And the nice thing about it is it's chlorine free, so your waste disposal costs are reduced. Which leads us to this product, Simpulse 58 MP, same genetics, if you will, of the 53 MP, but this one does contain chlorine, and chlorine does provide a good extreme pressure lubrication for ferrous materials. So the chlorine reacts with the iron in the ferrous materials, forming an iron chloride, making the cut much more efficient. So this is a little bit tighter emulsion than the 53 MP. Aluminum's like a little bit of a loose emulsion, i.e. that's why the 53 MP works well. The 58 MP is tighter, making it a little bit cleaner when it comes to machining steel and or ferrous materials. It is also triazine free, has good hard water stability. And because of its cleanliness, it's a very clean product, making it easier to wash. And it has good foam control for high pressure situations. So thank you.
So next, we're going to talk a little bit about how do we control these systems? How do we control the chemistry in the plants? So we have a pretty extensive laboratory. You can see all the different equipment. I won't go through it all here, but suffice to say that we've got anything we need to test the fluid. You know, we're oftentimes helping our customers resolve problems, find the root cause of the issue. I was on the phone this morning with one, and it really isn't related to our product, but we help the customer figure it out anyway. So we do have a lot of capabilities. This is kind of the work that we'll do in the laboratory. And this is what we do on site. And, you know, here we're talking system control, and when we talk that, let's really think of it as sustainability. That recycle, reuse. Try and get everything we can out of it. We bring these chemistries into the facility, and then if we treat them well, treat them nicely, they'll perform well for us, and we'll get the maximum life out of them. If we treat them badly, they're going to disappoint us. And, in that disappointment, there's all kinds of pitfalls we'll go through. But the most important of all of the things that we can do in the plant is check the concentration. If we run these products in the concentration range that's recommended, we're going to be really, really pleased with the performance. Matter of fact, we did an analysis, and you have to forgive me, I don't have the number right in front of me, but it was in the 80s again, where because we get thousands of samples in our laboratory. So we did a little analysis, and we found that over 80% of the samples that came in, the problem was directly related to the concentration control. So it's really critical. It's the one thing that on site we can do. And I think that especially with the refractometers are available today. We've got the old fashioned one, which I still carry in my backpack, but we also have the digital ones. There's really no reason not to check the concentrations on a regular basis. A lot of our customers want to go a little farther. They'll be checking the pH. They'll be checking the water quality. We oftentimes for our customers will run water samples for them at least annually to make sure that the equipment they're buying is performing the way they expect it to, or did the water quality shift? We had a funny conversation with a public works in Wisconsin, because one of our chemists noticed this huge disparity in the water, and he just took the initiative. He was a geek like me, and he decided to pick up the phone and call him. And the guy's like, "Yeah, we shut one of our wells down for maintenance. How did you know that?" He goes, "Oh, your water, for our customer, it's like completely out of whack." And he goes, "Yeah, we're using a different well for that right now." But he goes, how did you figure that out?" And it was just the lab data showed us. So another thing we can do on site, reduce the tramp oil contamination. There's lots of great equipment out there to do that. And there's shop vacs. And I was in a plant down in Texas a handful of years ago, and the bracket had broken off on the little oil wheel that they had, and there was ton of oil, and the machine was smoking. And I said, yeah, just get me a shop vac. And everybody kept going, "Oh, I think we got an extra oil wheel in the crib." And I'm like, "Yeah, just give me a shop." And I got a shop vac, and I sucked it off, and the smoke went away. So sometimes there's easy ways to do it. I know we all like to have little gadgets, but sometimes just sucking it off works out too. You can monitor the biological contamination, but it shouldn't be necessary if you're maintaining the concentration. And then you want to optimize the filtration system. There's a lot of permanent media out there now. So there are ways that we can help minimize the use of that. So as I mentioned, this is the old-fashioned handheld refractometers. It gives you a Brix reading on the scope. The one on the right shows you brand new coolant, nice sharp line, the emulsion's nice and tight, all that good stuff. The lower one is older coolant that's indicating that tramp oil is starting to come into the solution. It's starting to weaken the emulsion. So that's actually one of the things we can actually use this for, other than concentration. But its main value is that it will give us a reading, and then we take that reading, and there's a factor that the supplier will give you. Ours are on all of our product data sheets, and the factor might be like 1.5. So if you get 3, then that's 4.5%. So it's that conversion doesn't give, so the refractometer doesn't give you an exact concentration. It just gives you a number to use the conversion factor on. So what can happen when we're not in that optimum range that I referred to? Well, if we're low, we can get corrosion, not just on parts, we can get it on the machine, and these machines are expensive, so that's not something we want to do. We'll get reduced performance, meaning we'll get poor finishes, we might get reduced tool life. You might get some harmonics. I was in a plant in Mexico a few years ago, and I mean, it was unbelievable. Everything was squealing. And I said something to the plant manager who was showing me around. And when we finally got a product in there, we made sure it was at the right concentration, all that kind of stuff. And the harmonics just completely went away. So it is another indicator you'll get. You'll also get bacterial activity in the fluid if it's below the operating range. If we get too high, dermatitis. And this is, again, I can't emphasize how much we want to avoid ever having this. That's impacting a human being. It's not fair. Nobody has to work in a hostile environment. We don't want them to have a dermatological issue. And one of the bad things is if ignored, it just gets worse. And so people become sensitized, and that would be terrible, that they would be regulated to maybe some dry work job because of that. If we're at high concentrations, we get heavy residues, excessive foam, excessive usage. And, I love this little picture here. You see the foams coming out of the sump there. And if you look real close, that little bottle with the black cap, that's defoamer. That's often what you see. You'll see a bottle of defoamer there, and it's like, yeah, either we got the wrong product, or we might not have it at the right concentration, or we even might have added too much defoamer. So it's system control. Check the sumps with a refractometer daily. And daily isn't a lot to ask. Maybe every shift, or maybe the beginning and end of every shift. And I've done operator training a million times on refractometer usage. And it's really cool, because if we take the time to let the operators know that this is important, they'll do it. This is their work environment. So, you also only want to add, clean water or pre-mixed coolant, keep the systems clean, sumps that get, I've been there where they've shoveled out a sump and there's like 12 gallons left in a 50-gallon sump because the chips displaced everything. If there's oil leaks, do your best to fix them, and don't use the sump as a garbage can. We're again, sustainability. We're trying to get as much out of this fluid as we can. We don't want to mistreat it. Water quality. We've talked about that a little bit before. So, we can have different categories of water, very soft, moderately soft, slightly hard. Some of these are downright unacceptable. I mean, we get over 300 parts per million. It's really, really hard water. So I have a customer that we do business with they're a tube mill, and they actually truck their water in because I don't think they're settled in on this location. I think they might be moving soon. So rather than buy a DI unit or an RO unit, they're just trucking their water in, but it's really high quality water. So we're doing great. So you'll hear parts per million and then grains per gallon. And grains per gallon, it's just 17. So for every part per million times 17 gives you a grain per gallon. So you talk about, I'm from the Chicago area. You talk about, Great Lakes water at 7 grains per gallon. So it's kind of the optimum water for us. But we get downstate Illinois, and all of a sudden, the water coming out of the tap is, it's going to be 17 to 20 grains per gallon because of the way it percolates through the limestone. So you can check the water hardness. There are some nice, easy to use strips. They have ranges where they'll give you the readout. It's kind of like if you have a pool or hot tub, you might have something like this. You can check it, but also if you've got good water, you should get it pretty consistent. But I would at least check it annually. And then pH. I get a lot of customers that want to do this. I don't recommend the 0 to 14. There's some specific pH paper that's in a tighter range, like 6 to 12 or something like that. We want to get closer into our range, but this just gives you an idea of the pH. When we start talking about, down towards 0, it's very acidic. We get up into, like 4, we're talking about wine or vinegar, things like that. We get into 7, we're talking about water, and we get up around 11, we're talking about ammonia, or how about 10 is soft soap. So on the lower end of the scale, we're talking about acidity. In the middle, we're talking about actually neutral, and then towards 14, we're talking about the basic side. So when we get above 10, that's another dermatological irritant. So you're going to find most of the products are going to operate between that 6 and 9 pH scale. So filtration, I mentioned it before. There's, your typical, it's still used today prevalently, gravity filtration. permanent media and consumable medias. Obviously the permanent media is going to be very popular because it doesn't have to be replaced. It doesn't have to be disposed of. Again, reading that sustainability, it's very important. You'll have vacuum filters or pressure filters. It just depends where the force is coming from, if we're pulling it through the filter or pushing it through the filter. And then you get bag and canister filters, cartridge filters. These all need replacements. And then you get centrifuges. They're terrifically effective. You just have to be prepared to do the maintenance on them. They're a very sophisticated piece of equipment. I guess I wouldn't know personally, but I guess like owning a Ferrari. It seems like they probably require a lot of attention. So do centrifuges. Bacteria. So the water-based metalworking fluids, these are great environments for bacteria. They provide emulsifiers and surfactants and rust preventatives, which are great sources of food. They grow rapidly. So a generation is every 30 minutes. So that's fast. I mean, these guys can really, really get going. So we want to protect the fluid as best we can from these little guys because they'll consume the emulsifiers and surfactants, and all of a sudden we'll end up with heavy residues and smells and all that kind of stuff. So I jumped to that next slide. Sorry about that. Whoop. Go back one, please. Thank you. So like I said, some of the effects of the bacteria: odor, rust, because we'll split the emulsion, so we won't be delivering that little bit of oil that's dispersed in the water. We'll end up adding a lot more product. We'll lose lubrication. We'll impact the finish, impact the tool life. Like I said, loss of detergency. We'll end up with like heavy residues in places, and the pH will go down because the byproduct of the bacteria is an acid. And if you thought bacteria is bad, fungus is even worse. So fungus, it lives in colonies. They call them biomasses or biofilms. Sometimes you'll hear the phrase agglomerations. They're single cell yeast and molds, but they adhere to surfaces. They like warm, wet, dark areas. They typically grow at the coolant surface line because it oscillates up and down. So they get a little wet, and then it comes down. They get a little dry, and they love that environment. So if you take what I just said, a lot of times these guys are going to grow places we're not going to see it, and that's the problem, because they can have some pretty big impact on the housekeeping. Clog lines, headers, filters. They have this musty, nauseating kind of a smell. And it go back to what I was talking about through the tool. Delivery of fluid. Well, what if that little hole gets clogged with fungus? All of a sudden, we're going to find out that is blocked when we start breaking tools. And some of these tools are expensive, so it's a real issue for us to avoid as best we can. And how do we control for bacteria and fungus? We keep the concentration in the operating range, and we do pretty darn well. So
All right.
Go ahead.
Yeah, nope. I was going to say, I think that's the end of the road for this presentation. Marty, Bruce, thank you so much for the good info. It's really good stuff. You can see their contact information there on the left side of the sheet if you have any individual questions. I think we're going to send this out to people. But before we go talking about what's going to happen next week and anything, feel free to type in any questions. We'll go through anything that we may have currently. So I guess the first question we see here is kind of, where do you see the industry going, on the metalworking end?
Well, there's a lot of studies going on. I mean, there's, we just discussed, sustainability. There's a lot about the environment. There's a lot of companies as well as regulatory agencies. We've got OSHA and NIOSH and EPA and DNR, and they're all actively out there, and they're working on studies to make sure that we're doing the best we can health-wise for the people that we're impacting, as well as the environment itself. There's been a lot of regulations where we've moved away from certain raw materials. One would be diethanolamine that happened a number of years ago. But the neat thing is, because of the industry we're in, We've got a group that is called ILMA, Independent Lubrications Manufacturers Association, which not only are we actively involved and have been for decades, but one of our folks, Lon Fanning, was a longtime president of ILMA, as well as other offices that he held there. And we actually fund our own studies. So the government has allowed us for the last 20 or so years to fund and actually kind of regulate ourselves. So as a result, we're right in the fighting line there, involved with the studies and staying ahead of anything that we think might be an issue. Right now, the two big ones that are raising their head are phosphates and zinc, and we use both of them in our products. So we're as eager as everybody else to understand and do the right thing.
If I may add to that, Marty, Bruce here. I talked about the Simpulse line and the tall oil fatty acid scenario, which is basically European gobbling up all the tall oil fatty acids from a botanical sense, right? It's renewable and all that other stuff. So which leaves little or diminished quantity, if you will, for the metalworking fluid industry. So that's why product lines like Simpulse are being developed to get around those shortage issues pending. Nothing in urgency right now, but we see it on the horizon that those types of chemistries may be going away for our industry.
Excellent. I do not see any additional questions. So with that, and to be considerate of everyone's time, I think we're going to put this to a close. Again, I just want to thank Marty and Bruce again. Thank you so much for the great information and the great presentation. Next Wednesday at the same time, you can find the link on the DuBois Chemicals website. We're going to have Dave Schimpf. He's our Vice President of Research and Development. He's going to kind of talk about low temperature and phosphate cleaners, phosphate-free cleaners, kind of where we can save money, where we see cleaners, where they've been, where they're going, kind of what the future of that is in the industrial setting. So with that, thank you all for attending. Thanks again to Marty and Bruce, and I hope you all have a great day. Thank you.